Okay, please continue having your lunch. Meanwhile, while you are having your lunch, let's hear a talk by Mr. Xavier Fouger from Dassault System, which is one of our partner in organizing World Engineering Education Forum 2017 in Kuala Lumpur. For your information, Mr. Xavier is a Senior Director of Global Program Academia Dassault System. I think the title of his talk is about from digitization of industry to digitization of engineering education. So meanwhile you are having your lunch, I would like to invite Mr. Xavier Fouger for his talk. Please.
Thank you. I will take the other one. Good afternoon. Do you hear me? Do you hear me in the back? I'm happy to disturb your meal. Have you heard about mad cow? Do you know that shrimps are the animals with the heaviest concentration of heavy metal? Do you know that there are pesticides in most of the vegetables you are eating? I try to catch your attention because I want to share some ideas with you about how digitization of industry is moving into education or could even do better in doing so. This is the only slide to read, the rest is images. There has never been a worse time to be a worker with only ordinary skills and abilities to offer, because computers, robots, and other digital technologies are acquiring these skills. So we will be competing, our engineers will be competing against machines. The same way I am competing against food. I advise you to read this book. 10 years ago, I was advising you to read The World is Flat, because that was the best book on the observation of globalization. The current best book on the industrial transformation we are in, I think it's this one, The Second Machine Age. Think about that. We do often the mistake of calling this fourth industrial transformation Industry 4.0. It is true that the German initiative called Industry 4.0 has influenced and inspired many other governments to take similar initiatives, manufacturing modernization initiatives, which basically take advantage of the power of the digital age. Each country has such an initiative. Each significant country has a government-led, orchestrated activity in support of the modernization of industry. They are all different. Such an initiative in India is not the same as in Germany. And even the one in Germany is not the same as in France. The nature of things happening there depends, for instance, on the demography. If you are an aging country like Germany or like Japan, you would not have the same industrial policy than a country like China or India with a high rate of young people. But all of these initiatives have many things in common. They have policy instruments in common, and those policy instruments include academic and learning programs, and they have in common the types of industrial methodologies that they are promoting in industry as well as in education. And this is all about producing things differently, producing smart stuff, systems with a lot of intelligence inside. It can be a factory, it can be a farm, it can be a building. It's about entrepreneurship. In some countries, industry suffers from small companies not being entrepreneurial enough. It's about new techniques for manufacturing, and we mentioned already in this conference additive manufacturing, which will change a lot the trades in the factories. You will not have workers who remove material, but you will have workers who add material, and engineers have to prepare their work. How to do that? It's different. The shapes of things made this way is different from the shape of things made using cutting techniques. And of course, the Internet of Things. The industrial Internet of Things. The system by which a workpiece will tell a machine what the machine has to do to the workpiece. And once that will be done, to inform the next machine what the next machine has to do. And if something is to be done in another plant or another factory, the system will trigger the logistic chain that will order the truck to move that piece to the next factory. Complex scenarios will happen there. Other manufacturing techniques, laser-based manufacturing, composite. And then the way we will produce will finally be on demand. I say finally because at the beginning of Internet, we all spoke about the promise of mass customization, producing only what is needed and in a personalized manner for the consumer who is purchasing. But now it will happen. Now it will happen that when you purchase a car, it will be manufactured just for you according to your preferences. We start to see dealerships in which you engineer literally your car, the car you want, by choosing very major options on your car, and that will trigger the production system. You understand, if you do that, we need a special engineering system. Customization will be generalized, and things will happen globally. Engineers will not work only with engineers they know, they will work with people who are sleeping at the time they are working, at the other end of the planet. Are we teaching that? Are you giving your students the experience of producing some result with people they will never be meeting with? With people they rarely talk to because they are not on the same time zones? So many changes ahead, and it is my job in the company I am working for to help educators like you in transferring these new practices into your educational work. So what I do is we take the ideas coming from the industry, for the new ideas about the new practices, and we shape them, we present them, we document them into a learning activity. A learning activity that heavily relies on the use of digital tools. Here you see a few examples, or you don't see because it's too small for you maybe, of things that can be used in your curricula right now, fully documented for education, such as the one I like here is the notion of the learning factory. It's a special understanding of that learning factory, and that is about students building their own small factory based on a new business model. For instance, a business model in which the consumer would finalize the assembly of the product. That's one example. This is an example. The one you see on display here was developed with a university in Germany, with a business school doing engineering, industrial engineering. Additive manufacturing. Additive manufacturing is not just printing little plastic characters for your decoration. It's much more complex. It is metal parts that are used in airplanes or the hinges of the latest BMW car. And these are specially designed for that manufacturing techniques because we want to use that new freedom that we have in creating any type of shapes. Composites. We are displaying on our booth here a composite-made car from a Malaysian university by students, but that's one example among many. Composite is used in many other industries, music instruments, for instance. In France, the government has already spent 9 billion euro, which is a big amount of money, 9 billion euro. I try to catch the attention with money, but it doesn't work. 9 billion euro for research and for industry support for that manufacturing initiative. And that includes cobotics, collaborative robotics. Robots now can work together with humans. Do we prepare students in manufacturing engineering? Do we prepare them to design work procedures that optimize both the performance of that collaborative work and the comfort of the workers? So there are many such ingredients that represent new practices and that are very relevant to teach or to use as an immersive exercise with students. That's my job, preparing such learning experiences for you. The challenge now with these national manufacturing initiatives is that most of the jobs of the future, again, statistics, we heard one this morning. This is another one from another source, published July this year. And never before has such a statistics been relayed by the press worldwide as this one. It may be exaggerated to say what they say, that 85% of jobs are not known today. Yes, if you move back 20 years before, 20 years back, would you have imagined the job of an Uber taxi driver? I assume your silence means no. And no one was imagining that. But you knew already the skills necessary for such a job. You knew one skill, the skill of driving a car. That's a hard skill. And you knew that if you are selling this service, you need to have some social skills. Politeness of the driver is a social skill. So we don't know the jobs, but we know the skills. We know the sciences that will be used. What can you do if you don't know the jobs? The challenge of education is this one. You don't know the jobs. But one thing you know is that your students will have to learn all their life. So one skill you have to give them is the skill of learning, the skill of solving problems. And you have methods, existing educational methods for that. One I like is CDIO. Who is familiar with CDIO? Okay, who is not familiar with CDIO? So if I add the hand, I have about 10% of the audience. I ask again the question. Who is familiar with CDIO? Who is not familiar with CDIO? It's getting better. The second methodology I love is PBL. Who is aware of PBL? Who is not aware of problem-based learning? Everyone is aware because we are hosted here by UTM, which is a temple of PBL in Asia, thanks to our conference chair, among others. So now we have this challenge of bringing the skill of learning, and we have these methodologies that bring actually this skill. It is a profound transformation when you move from course-centric education to project-centric education. It's not driven by the capstone, because usually you do the capstone project at the end. Who is doing capstone projects in your universities? Who is doing capstone projects in your universities? Who is not doing capstone projects? Very few hands. Well, my dream is to flip the capstone, which is very dangerous if you take the literal meaning of capstone. To do the project as soon as possible, as early as possible with the students. Of course, not with the same level of science, but with the same social knowledge that we'll acquire during the exercise. These two methodologies have things in common. At the same time, they address traditionally called soft skills and disciplinary skills at the same time. There is one sentence you are pronouncing almost every day. It is, the curriculum is packed. Because it is not a natural thinking in international education to try overlay learning times into a single activity. And project-based education is a way to overlay the human and social skills with the disciplinary skills. They have in common that they start with the more conceptual stage, the creative stage, something old-style engineers like you and me, maybe not the youngest one here, have never been trained for. We have been trained for differential equations. And now we should be speaking about creativity. How do we do that? These methods force the learning activity to address the ideation stage, collective exercise of creativity. It finishes by making. While I know PBL is not always prescribing a making activity, CDIO is prescribing one. It is important to have hands-on. It is important to see the prototype. If you are interested, we have that car from UTM that is exhibited on our booth, and that is showing what they have done. From design, from using computer-based systems to the actual production of a car. It has to be authentic. That's the official jargon of PBL. It has to reflect real life for motivation and for purpose. And it is a social exercise. You are not alone with the problem, you are in a group. And you learn how to deal with your peers, how to find consensus, how to negotiate an average solution or an optimal solution. This is taking a big momentum across the globe. There are many places where you see signs that the problem-solving skills are getting central to the educational programs, encouraged by, here, 3 examples. One, the National Academy of Engineering in the United States, when they gave the annual prize for engineering education innovation to a program that was centered on problem-based learning. The second example in France, where the accreditation agency is now strongly recommending universities to prove their efforts in moving their curriculum towards problem-based learning. And the last one is from India, where a current program funding the modernization of colleges of technical education by the World Bank was requiring, in the top requirement for the funding attribution, that the program proposed by the colleges to justify funding had to focus on the critical thinking and problem-solving skills of the students. I had the same situation as today, talking during a lunch, 1 month ago in Canada, but these were about 170 deans. It was the Global Engineering Deans meeting, and I was using a trick to compete against the food, which was to give them questionnaires. And this is the answer they gave to one of the questions I was asking, just to try to find out if they have actually a systematic or a partial exploration of a project-centric learning methodology in their institutions. And these are the answers. Most of them have, not always in a systematic manner. Still, about 20% say they do it systematically. And this I have hard time to believe. Systematically would mean that all their programs are problem-based and organized that way. Or I was happy in having the right deans in that room, but still the method is far to be generally adopted. There are challenges for that. There are huge challenges in transforming organizations to practice problem-based learning. And these challenges I tried to summarize here. They are organizational and they are human. That's why they are so difficult to overcome. The technical problem is the reorganization of the program schedule. That's a technical problem. How to make sure that everything can be aligned on project activities. How to establish a common cross-disciplinary culture. In a profession, educators, that has been growing along its career just because of specialization, not because of cross-disciplinary work, just because of research, not because of education. Transitioning from what I am doing now, from the I teach position, to the they learn paradigm. It's a difference of attitude. It's a difference of self-representation of the teachers. And the last challenge is well, I don't know if it's the last challenge. It's another big challenge. It's the cost of organizing it. It is the limited time of project supervisors. You can only supervise a limited number of students. You need to, ideally, you would spend the same time with them as the one they spend in their project, which is not possible because you have other students to mentor. And this is where we come in play. In industry, we do projects. The work of industry is basically to do that. We don't do lectures, we do projects. And we go through these 3 steps: inspiration, innovation, creation. And then you can break down in the different functions within a company. And this is easily transposable into a project-based education activity. With one exception, is that you need to do more than these 3 things with your students. You need also to accomplish your academic goals. You need to make sure they are learning the knowledge. You need to make sure that they find the knowledge they need to solve the problem they try to solve. So it's a pull of knowledge by the students instead of a push of knowledge by the educators. And also you need to evaluate their work, which is so often group-based. It's group work. How do you assess the individual contribution in a group? How do you assess the process of their project activity and not just the result? Do you have a movie that is showing what they have done during the project time? Or do they have to tell you? They have to tell you. Yeah, 1 minute. And this is where we come in play, because this platform, we have developed a platform for projects in industry. This platform we have adapted for education. It is a platform for project. We have made it a platform for project-based education. It is called ILICE. If you want to learn more about that, we show it on our booth and we distribute documents on the Dassault system booth outside. It is really a platform that creates, it's based on our standard tools that you may know. You know CATIA, you know SolidWorks, you know Abacus. There are dozens of things here that I am sure each of you know at least one of them. And this constitutes what we call the 3D experience platform, and on this platform we have parameterized this ILICE framework for project-based education. And it presents in the same digital environment all tools that help each of these 5 steps: inspiration. When you ask students to solve a problem, what do they do first? They go on internet and do an internet search based on an unstructured approach. This can be structured as we do in marketing for industry. So these tools are available here. And so on. You go to the learning step where the tool presents you all digital resources you want to have them use, refer to, in support of their problem-solving activity. Innovation, brainstorming, digital brainstorming with people who are not necessarily at the same place. Brainstorming with Post-it has one enemy, the cleaning stuff in the evening that removes the Post-it from the walls. So you forget ideas that could be reactivated later on. Creation is a traditional engineering process. Here you do what you are used to do. You use the system to design a solution. You do project management. You do design. You do manufacturing planning. You manufacture a prototype. And in evaluation, you have many tools from that system that are available. I will not talk about it because on the booth we have a specific paper just on that aspect of the evaluation tools that you can find in such a platform. We have done that in high schools. We have done that in universities. We have great existing projects that are multinational projects in which the problem was solved across 12 universities on the planet. And we have similar projects done successfully in high schools across Italy, Germany, and France, funded by the European Union. Kids speak bad English and good digital language. And finally, we are in the process now of working with my friend Annette Kolmos from Aalborg and my friends from Colombia on a new experiment of applying this type of framework in project-based education across the ocean. With that, I really thank you for giving me some attention despite the poisonous food you have been eating. And then wish you a nice conference. If you want to learn more about this story, we are standing outside. We have a team here to answer all your questions. Thank you and enjoy that conference.
Thank you very much, Mr. Xavier Fouger from Dassault System. Few things that he has been talking about, highlighting the future of how learning should take place for the fourth industrial revolution.